I would say since around middle school, when I was in 7th or 8th grade, I was very interested in mathematics as a subject more than computer science or anything of that sort. I was very much into statistics, calculus, things like that. I used to buy books from outside school and study them on my own. So I started off as more of a mathematician than a computer scientist or machine learning person. And then in around, I would say, ninth grade, couple of years, like maybe 3, 4 years back, my father, who's also a data scientist, he introduced me to this website called Kaggle. And the moment I found Kaggle, I just fell in love. I fell in love with the concept of machine learning because machine learning is not simply computer science. It's not engineering. There's so much maths in it. The algorithms, the processes. They have so much calculus, statistics behind it in order to work. So that's what made me interested. So for a lot of people, they get interested in computer science and then they move on to machine learning. For me, machine learning was how I got introduced to computer science. So came from the opposite direction. When I started participating on Kaggle, when I started competing in competitions, I didn't really have any fixed goal like I want to win certain number of medals, I want to win prize money, or I want to crack this competition or do really good at this. None of those things were in my mind. Like initially I was just in love with the concept of machine learning, with how you can like collect so much data and how you can extract insights from it automatically without human intervention. That idea itself, I just fell in love with it. So picking up random data sets, picking up random competitions, getting my hands dirty with those data sets, building my own models. Even if I finish in the bottom 10% of the leaderboard, I didn't care. I just try to learn as much as I can and enjoy. So Kaggle was more like a fun time hobby when I got started. Like I looked at it as something to keep me occupied, something that was fun. I'm not a person who likes being idle, so this was a very productive way to fill up my free time. So I never really looked at it as some sort of chore or as a burden or something I need to succeed in. I just looked at it as something that kept me occupied and kept me interested in something. Like I mentioned earlier, right? I took the opposite route from what most people take. A lot of people, they learn computer science, they learn the core basics, they learn how operating systems work, they learn how to manage the command line, memory management. They learn all these core computer science concepts. Then they go to machine learning. They start learning machine learning algorithms, and then they start with maths. So since I came on the opposite track, maths, machine learning, and now computer science, I feel like college is filling in a lot of gaps in my learning and my understanding, which I never thought I had. So, however good you are at understanding the algorithms, however good you are at understanding the maths and the formulas, you need to be spot on with how a computer works and how memory works, how operating system. But since I came on the opposite track, these things are kind of filling in the gaps that I left when I started with maths. So I feel like after I finish my 4 years of college, I'll probably be much more well-rounded as a machine learning engineer because I'll know all the core computer science, which I kind of ignored when I started. So there are a couple of things. The first thing is obviously Kaggle. So Kaggle, as we all know, it's a gold mine of high quality data sets, high quality problem statements from businesses. You get access to real world problems. You get access to discussions and notebooks from the very best in the game. So Kaggle was just a great way for me to become good at machine learning as a field, become good at, cleaning data, pre-processing, improving my modeling skills, basically the core machine learning concepts and algorithms. So Kaggle is a great way to learn that. Just I just joined Kaggle, and from day one I started, playing with data sets and getting my hands dirty. So Kaggle is a great practical way to learn. So I highly recommend Kaggle. But the second resource, which is open source contributions and GitHub. this is not exactly a resource, but it's more of an activity that I did that helped me improve. So the thing with Kaggle is, when you write Kaggle notebooks, when you publish Kaggle notebooks or you participate in competitions, no one's checking your code, right? No one's looking at how high quality your code is, how elegantly it's written. They don't look at how efficient it is, right? But as soon as you step into the world of open source and GitHub, and you're trying to contribute to a repository like Keras or PyTorch, right? Your code needs to be spot on, right? You need to write very high quality, efficient, clean looking code. That's something you don't get to learn from Kaggle at all. So Kaggle is a place to learn machine learning, but it's not a place to where you learn how to write good code. So I started contributing to open source repositories a couple of years back, like Keras and PyTorch. I just started, opening issues, issuing pull requests with new features or bug fixes, even documentation fixes, anything. So participating in that whole open source environment, that process, I think it really helped me become a better programmer. So Kaggle made me better machine learner, but GitHub made me a programmer, a better programmer, right? It introduced me to the world of, these coding guidelines and how people write code that's production ready. So that's one thing. And last but not the least, I would say all sorts of mathematics resources, right? They're the backbone of anything that's related to machine learning. So I would highly suggest uh, MIT's Open Courseware series. That's about mathematics and linear algebra, statistics, and all those things. So these three things, they covered kind of three corners of the triangle: machine learning, computer science, and mathematics. I feel like if you can be relatively good at these three things without being too weak at one of them, you can keep up with the field and you can participate well on Kaggle. I would say as a 16, 17-year-old, the main challenges that you'd have is obviously time management. Because actually, when I started Kaggle, I was, I think, 14 or 15. And at that time, I was just transitioning to high school. And it was keeping up with schoolwork, it's in itself was very difficult. And at that time, when I was in ninth grade, I had an aspiration to uh, try to get into IIT maybe when I pass out 12th grade. That ended up differently because I ended up going on the international route and uh, the SAT and going to a college abroad. But at that time, I used to go to an IIT coaching center on Saturdays and Sundays, and that consumed a lot of my time along with high school. So a lot of academic pressure like suddenly came onto me when I was in ninth and 10th. So that made it very difficult for me to manage my time and dedicate time to my hobbies like Kaggle. So my main challenge was to just manage my time and make time for things like Kaggle. So instead of making Kaggle something that I push aside as a second priority, I try to keep Kaggle at the forefront and somehow manage everything else. So what people usually do is they keep their school work, they keep their coaching, whatever IIT coaching, they keep it at the forefront. That's their life. That's what they do. They need to score marks in their exams. And their hobbies, I can do it next week, I can do it next month, kind of thing. So they don't take it that seriously. What I did is I dedicated time to Kaggle and my passions I put it at the forefront. I made it my first priority to spend time on Kaggle and become good at machine learning because that's what I like doing. My priority was never to be first in my class or score really good marks or anything like that. So because as a ninth or 10th grader, especially in India, there's a lot of pressure in general from not only from teachers but from in general as a society. So to go against that notion and to pursue what I love doing and push aside things that I don't like doing, that was a tough decision to make, but I really feel like it paid off after a couple of years, because I don't think I would have got this far. I don't think I would have become a grandmaster in notebooks or a competitions expert if I just pushed aside my passion. So that was the most difficult thing, going against the way people usually approach things. Looking at setting my priorities a little differently from what's conventional. So the first one I would like to talk about is, if anyone in the audience was on Kaggle in maybe 2017, 2018, they will know the plastic competition. It's basically a tabular data competition, and it uses astronomical data. So you have like data of stars and planetary objects, and you have to make some predictions based on that. I don't exactly remember what the problem statement was, but I think it was based on the positions of stars or like objects in outer space over the last couple of days. You have to predict where it will be the next day. So it was kind of like a time series sort of problem, and you were given data and CSV files. So at that time, I was just starting to learn deep learning and all these cool concepts and buzzwords. So I forked someone's notebook, which solved this problem with neural networks. I just forked it, and I added my own few adjustments to it. So, for example, genetic programming, right? Neural networks have a lot of hyperparameters. They have a lot of parameters that are tuned by hand. So, using some built-in library, I wrote code that finds the optimal hyperparameters on its own using genetic programming. So at that time, that looked really cool to me, like something that's meant to be done by humans, tuning hyperparameters by hand. It can be automated with the concept of genetic programming and survival of the fittest, that kind of a concept. So at that time, that looked pretty really cool to me. So I just implemented it with genetic programming, and I published it. And at that time, I had no notebook medals, nothing. I never, not even a bronze medal. And this was the first notebook which got me a medal of any sort. It was my first bronze medal. And that's honestly the only reason I remember it. You always remember the first time something happens, right? So this was special because it was my first medal. Um, so that's the first one, plastic. The second one is from a competition called VSB Powerline Fault Detection. So if you were on Kaggle, I think maybe 2019, you would probably know this competition, early 2019. And basically the problem statement was that you're given electric signal data from a power line. So it's like time series data of an electric signal, like voltage signal. And based on the signal, you're supposed to predict whether the power line is faulty or not. So based on some patterns in the signal, you can figure out whether there's some dangerous fault in the power line. So people don't need to manually go to the power lines and inspect it. They can have algorithms that predict it and address these faults really quickly. And so VSB is a company that came up with this problem statement, and it was really interesting to me at that time because I never really dealt that much with data that's from the natural world. So mostly I was dealing with data that was like stock data, some sort of tabular data like Titanic or something like that. So this one was really different, like an electric signal, like the idea of doing machine learning on electric signal was cool, and I just picked it up. And this is also this is another fork. Okay, so someone made a notebook for this competition where they solved it with LSTMs, long short-term memory networks, which is like classic for time series. And this was my first experience with LSTMs, and dealing with signal data. So I just forked this LSTM kernel because I sorted the notebooks by best score, and I saw that the LSTM notebook was on top. So I just forked it, and then I did something that I never did before. So I looked at the data and I manually engineered features by hand. So I actually looked at the data and used like domain knowledge, physics knowledge to engineer features for this data set and integrate that into the LSTM model. So like if you know like entropy or like fractal dimension, these are concepts in signals. So it turns out that uh, if you calculated the entropy or like the fractal dimension of these features, it's a good indicator of whether it's faulty or not. because you can figure out from certain irregularities and higher fractal dimension or higher entropy that the signal is faulty. So I calculated these features and integrated them into the LSTM model manually, and my notebook achieved the highest score of all public kernels. So that was the first ever time I had the highest scoring notebook in any competition. This was the first time I really felt like a data scientist, right? This is the first time I really felt like a data scientist, because it didn't feel like plug and play. Just take the data set, plug it into an architecture, and the output comes out. It made me feel like there's so much there's so much art behind data science. There's so much manual labor behind it. It's not that easy. So this was the notebook that made me realize that, and that's why this notebook is special to me, because it introduced me to the real complexity of machine learning, and that machine learning is a lot more than just models, right? So that's the second one, VSB competition. The third one is the highest scoring, the highest voted kernel I've ever made, the highest voted notebook. It's from the Lyft self-driving car competition, which happened, I think in sometime late in 2019. So that was an autonomous driving competition. Basically, you were given 3D data of like a street with like cars and people, and you had to detect the objects in the 3D data. So it's like a 3D point cloud of people, cars, and everything, and you have to like identify. So, like I mentioned earlier, I made maybe over 70 notebooks in my whole Kaggle career. So, in the beginning, I found it very difficult. You know, I never really tried or wanted to get upvotes in the beginning. But then, as I started doing more and more Kaggle, I thought, okay, it would be nice if my kernels got some upvotes, because in the beginning, I just used to make dozens of kernels, and no one would ever notice its existence, right? So I thought, okay, this is boring, right? I'm just making simple notebooks, and no one's ever engaging with it. No one's interested in it. So I started thinking, how can I make good notebooks, right? How can I make notebooks that get upvotes? How can I make notebooks that are useful to people, right? It's not just a mind dump. It's not just something random. It's something that helps people, or people appreciate. And it took I sat on this for several months, and I never really got an idea of how to do it. Like, I kept struggling for like maybe 2 years, just making notebooks and no one ever noticing them. And honestly, I started to get a little frustrated about it, because as like at the end of the day, notebooks are content, and you're a content creator. Even though it's machine learning, at the end of the day, it's like a blog, it's like content. So you want people to notice it, you want people to find it useful, because you get that's a gratifying feeling, right? When you make something and people appreciate it. So out of my frustration, I just posted something on the Kaggle forum. I posted saying, okay, I'm really frustrated, I'm only a Kaggle kernels expert, I want to become a Kaggle kernels master. But no one looks at my notebooks. No one sees it, no one notices it, no one upvotes it, no one comments on it, nothing. So I made a post ranting about how no one sees my notebooks, and somehow, by my luck, uh, Kaggle legend Andre Lukinenko, he replied to my post. So I was surprised when I saw that someone who I looked up to replied. So basically, he said, notebooks that are just a mind dump, notebooks that are just a few lines of code and thousands of lines of training logs, they're not going to be helpful to anyone. They're not going to be helpful to anyone. So you need to do something that others find useful or interesting. Basically, that's the bottom line. I don't remember exactly what he said, but he said you need to do something that's unique to you. Something like, when someone sees a kernel, they should know that this person made it. Like, you should have your own style of making plots. You should have your own style of explaining concepts, your own style of writing training code, your own style of everything. It should be the analysis and work of the person making it. Has to be unique and special to that person. That's what he said. And I just after I read that comment, this was just my guiding principle for every notebook I made. There was literally no other guiding principle. Make something that's special, something that you would upvote, something that you would find useful, something that would get you out of trouble if you were a newbie, something that will solve your doubts if you were new to machine learning. So I just keep this in mind when I start a kernel. And when I'm working on it, I'm training a model, I'm explaining concepts, I'm plotting graphs. I just keep asking myself the same question. Is this just one of those kernels that's 5 lines of code and 10,000 lines of training accuracy logs? Because it shouldn't be one of those, because you're not going to get votes from those. So just keep that in mind. It's something that you need to do with love. Like you need to pour everything into it, because that's when it will be special. I would say two. If like I can mention maybe two libraries that I use, which are not considered mainstream. So there's a library called Polyglot. I'm not sure if this is considered famous or not. So Polyglot is basically it's a very convenient NLP library, and it's not a big library like Spacey or NLTK. It's a very small library that does very few things. So the main thing Polyglot does is it's basically NLP for multiple languages. So like if you're solving an NLP problem in Arabic or like Telugu or some language which is not English, you will want utilities like language detection, language translation, things like that. So it's just really this really neat library which has a bunch of utilities called Polyglot, which I use a lot. You can see it in the name itself, Polyglot. I think it means like someone who knows multiple languages. So I came across this during the Jigsaw multilingual toxicity competition, because I needed to deal with multiple languages and do translation. If I had to name another library, I would name this library called Pattern. So Pattern is also really good. It's not like Polyglot. It doesn't support languages other than English, but it has this really really neat API for classic NLP utilities like part of speech tagging and sentiment analysis. Pattern is it's a really neat library, and it does very few things, just like Polyglot, but it's very useful. Like for an entire kernel, I wanted to use part of speech tagging, which is like a way to generate features in NLP, just like TF-IDF. So I completely relied on Pattern for the entire analysis. So NLP is not just deep learning, right? There's a lot of processing and like I mentioned, TF-IDF, POS tagging, sentiment analysis. So Pattern is amazing for all that. I would definitely suggest checking out Pattern. I would say social media is a great way to stay updated, because you may not believe it initially, but if you're on Twitter and you follow the right people, you follow the best researchers at the best universities, and you follow industry leaders from top companies, you just follow what they're tweeting. You're gonna be updated, with 99% of the things that are happening in the field. So just stay connected with people who are revolutionizing the field. Stay connected on social media. They usually share links of new research that they're working on, new papers that they're working on, and industry leaders keep talking about a new product that they launched or a new idea. So I just make sure I follow the right people on social media, and like Twitter or LinkedIn, etc. And you just need to swipe through your feed, and you'll see everything new that's happening, everything that's trending in machine learning. And I think this is really important, because like if you're not going to stay updated with the current state of something, you won't be able to do research that's built on top of that, right? You're not going to build everything from scratch. You're not going to revolutionize the whole field with simply by yourself, right? So I've recently been working on a couple of research ideas that I have on my own, and a lot of these ideas are inspired or built on top of research that others have done in the field, that other researchers or industry experts have done. And so I feel like, being in a closely knit social network where people discuss the latest advancements, it really boosts your potential as a researcher. Because just by swiping through your feed, you can see everything that's happening, and you can think, okay, what if I do this? Won't that take this idea to the next level? So this interaction on social media really helps me a lot to come up with my own ideas for research. I follow people like Boyan and Andrei Lukinenko, to name a few. These are some Kaggle legends. They've won everything in Kaggle competitions. They participate in the community. So I make sure I follow these Kaggle legends. I just make sure you follow all of them and you follow what work they're doing, because the kind of things they do, it's industry leading work, right? So I make sure I keep up with what these Kaggle GMs are doing, most of them, and of course the legends of the field, uh, Geoffrey Hinton and Joshua Bengio. These two wrote a book called Deep Learning, which I read a couple of years back, and that was very important for me once I left the pure mathematics space and I started doing machine learning. This was the first book that I read, and it was really useful for me to grasp how all these algorithms work. There's absolutely zero code in the book. There's no programming. It's just the core concepts, the algorithms, and how they work. So these two Kaggle, machine learning legends, and also Andrew Ng is also someone I look up to. He's an excellent educator. He's not only a brilliant researcher and he's not only a brilliant machine learning researcher, he's also an excellent teacher. If you've watched any of his courses or course videos, and so I really look up to Andrew Ng because I've learned a lot from him. I would say, set your priorities straight, right? Do not make something your fifth or sixth priority and expect to achieve something great in it. Like, what I did is I just joined Kaggle and I made it my priority immediately. So if you make something your priority, if you put your heart and soul into it, whether you're making notebooks, whether you're trying to win competition medals, whether you're trying to do both at the same time, which is what I am trying to do right now, hopefully, you will make it. It doesn't matter if you're a school going student. It doesn't matter if you don't have a PhD. All those things don't matter, because when you do something that you're passionate about, when you try to achieve something in an area you're passionate about, it feels more like a game. It feels more like a game than a household chore, right? If something feels like a household chore, it doesn't matter how much you achieve in it, because it's not going to give you fun. It's not going to give you happiness. So pick something that really makes you, that keeps you awake at night. Something that you don't mind debugging the whole night. Something that you don't mind dedicating everything you have to it. Something that you don't mind sacrificing other things to get. So once you find something like that, there's nothing that can come in the way. Nothing. You just need to keep your focus on it, and you know you'll be good to go. Doesn't matter if you're a school going student. Who made these rules, right? You don't need to be in at a particular age or a particular qualification. Kaggle doesn't even have an entrance exam. It doesn't have an entrance exam. Just join it and get started. What's the harm? It doesn't matter if you don't achieve anything. You know just join. Just you won't win anything if you don't join the game, right? So just get started. That's all I would say.